Hey guys, welcome. I hope everyone had a great weekend. It was December 5 yesterday, a Sunday, and you have a great start to your Monday morning. And I titled this integral the Trump integral because, I'm trolling a little bit, but because basically, like, it was very stubborn when I was trying to do it on my own, and I had to like look it up. Like, there's a really good online integral calculator. You could literally just search integral calculator and follow the first link that pops up. Try to use any other search engine but Google. Anyway, anyway, that's a really good tool if you're stuck on an integral. And it turns out that there's like a very inventive piece that I was missing at the start, and you will see when we encounter it. But yeah, let's get on with it, right? Okay, so this is the integral we're doing, right? And so it's pretty obvious that you should rewrite this 4 as 2 to the second power. And so that's the first thing you should do. So then, back-to-back exponents, say multiply the exponents, so we get 2 to the 2x, right? Once we rewrite this 4 as 2 to the second power. Okay, so this is the very inventive piece that I spoke of, which is to now multiply the numerator and denominator by the natural log of 2 times 2 to the x. And you'll see just why. Well, basically the idea is that like this is what you'd want to claim as u, 2 to the x plus 1. And so the derivative of that is going to be the natural log of 2 times 2 to the x. Right? And by the way, if you don't know how to take the derivative of an exponential like this, I have video on that, so you ought to check it out. So now, what I've done here is exactly following this advice, multiplied by the natural log of 2 times 2 to the x over the natural log of 2 times 2 to the x, thereby multiplying by 1. Also, I must add that one of my favorite students on here, Brar, told me to like narrate over my videos. He doesn't like the quiet videos, and so I decided to grant his wishes. And there are a few of you that like asked me to do request videos. Like, I just can't do that. My time is like really precious. Like, I have a lot of things I want to get done. Blah blah blah. But on rare occasions, I will make exceptions. There was a student recently who asked me to make his own integral, and I said yes, and he seemed so excited, and I feel really bad for letting you down. I'll get around to it at some point, so I will make rare exceptions, as I said. But I don't take requests. Because if I do that for one person, then I could spend my whole day just fulfilling requests, right? Like, ain't nobody got time for that. Anyway, as I said, u is going to be 2 to the x plus 1. That's this here, right? Okay, so then, as I also said, unsurprisingly, du is going to be the natural log of 2 times 2 to the x dx. Notice that we've got the natural log of 2 times 2 to the x dx here, all in the numerator, right? Technically this is in front, but technically it's in the numerator. So we can put this and this together and claim it as du. And obviously we're going to claim this as u, right? Okay. So then that means that this is where we're at, right? Okay. Can I talk in ebonics the rest of the way? Can we just have fun? Because this is like a trolling integral anyway. Yeah? Alright. Alright, so from here on, what we do next, what we do next is, well, since u is, sorry, like that's really like, I might accidentally like sound like I'm making fun of people. I can talk in ebonics, so I'm just like showing my flexibility, but please no one take offense to this. So u is 2 to the x plus 1, so then u minus 1 is 2 to the x, and all I did there is subtract 1 from both sides, and sorry, and so then we squares this on both sides, and we get u minus 1 squared is 2 to the 2x on the right side, right? I don't want to make fun of people for like cultural reasons. I used to be made fun of for like talking like a white boy when I was in high school, and I'm like, dude, I was just I'm just talking like regular grammar and like good diction and stuff. Anyway, anyway, let's get back to it, right? Okay, alright, I'm gonna stop clowning. So, u minus 1 is 2 to the x, that's right there, right? So that's right there. And this u is right there, right? Okay? And sorry for getting the color coding there. Then otherwise, 2 to the 2x, that's u minus 1 squared. So we have u minus 1 squared plus 1 in the numerator. Okay, now, because this integral was going to be too long, I skipped a few steps, but you know, they're simple steps, steps that you should know how to do if you, you know, are advanced enough to be watching this integral. All right. So this is just long division. So if you do long division on this, then you should be able to see that you could claim it as same as this. So basically get common denominators here, right? One is u times u minus 1 over u times u minus 1, and you'll see that you'll get to the same place, right? Okay. All right, so then we move forward from here, separating into two integrals. We lead with the 1, right? So 1 du, and then the rest of it is this. Both, of course, when we separate them, the linearity of the integral, right? Like, when we separate them, they both involve 1 over ln of 2 here and here, right? Okay, and this here is going to turn into just u, right? We'll get our plus c later. And so then this is the other step that I skipped, which is that we've got to perform partial fraction decomposition on this part, right? And so if you do that, you get this. Now, I have many videos in my algebra videos on partial fraction decomposition, like covering you on all sorts, right? On all the different varieties of partial fraction decomposition that might arise. And so watch those videos. Like, the details are too simple for me to, like, you know, labor them in this video. And so then otherwise, moving forward, this here is the same as that. And so this is gonna, if we again break this into two integrals, it's gonna be 1 over ln of 2, that's the constant, times 2 times the natural log of u. And so I put the 2 here in the numerator, right? And then otherwise the natural log of u, and then minus 1 over the natural log of 2, and then the integral of this part is gonna be the natural log of u minus 1. And plus c, right? Okay, cool. So where to from here? Well, you see this 1 over the natural log of 2 is common to all of them. It's a common factor, so we can pull it out all the way in front. But then that would mean that in this part we'd have 2 times the natural log of u, and so that would be the natural log of u squared, right? Okay. Then where to from here? From here, we can come up to here, and all I did in this part is just replace what we said was u, and that is 2 to the x plus 1, right? And so then the final step is like seeing that 1 minus 1 is 0, so that's all I've done this final step. Now I was running out of space, so I just put it right down the middle, right in the middle. Again, like, y'all, I'm black, so like, please don't be offended because I like spoke in ebonics or attempted to. Like, it was just me being a clown as always, the Joker. Okay. All right. I hope you enjoyed this. Have a great day. Take care.